Hey everybody, this is the review lesson on geometry, part 2, that talks about surface area, volume, and area of compound shapes. Like we had discussed in class, volume is the space inside a 3D object. Surface area is the combined area of the outside of a shape or figure. Volume is written as a volume is expressed as cubic, surface area is expressed as square, and that's because volume is a 3D measurement, whereas surface area, like area, is a 2D measurement. In order to calculate both surface area and volume for the figures that we talk about in 7th grade, you need to know how to calculate the area of a triangle, the area of a rectangle or square, and the area of a circle. And remember that the relationship between the quadrilaterals and the triangles is that the triangle is half of a rectangle or square. And this also works for parallelograms as well. 7+ students, area of a circle is what you use for cones and cylinders. Cones and cylinders are not on the 7th grade EOG, but you do need to know that if you on the Math 1 trajectory for next year. All right, so let's look at how to calculate volume and follow this procedure. And this will work for all of the required figures that you have to work with. Step 1 is to find the area of the bottom of the figure. Step 2 is to multiply the area of the bottom by how tall that figure is. And in some figures that are triangular or pyramid, you'll have to do one additional step. For cubes and rectangular prisms, triangular prisms, this is what you need to do. On the screen, you will see 2D representations of the triangular prisms and the cubes and rectangular prisms. I had initially on the screen started to draw our pyramids, but as I was working this out, realized I didn't have enough space, so the following slide, or the subsequent slides, are going to have the pyramids part. So, when we're talking about cubes and rectangular prisms, the yellow in all three of these diagrams shows the bottom. So, in our rectangular prism, which is located here, you do 5 times 12, which is 60, and then the height of it is 6. 60 times 6 is 360 units cubed, and then you're done. The first one, this is the right triangular prism, and this is just a regular one, or you could even say that it is isosceles usually. But the process is still the same. In this one, where this is the math for this one down here, you would do 7 times 14, which is 98, then multiply that by its height, which is 8, that gives you 784, and then half that number is 392 units cubed. The bottom one, the process is the same. The bottom is 4.5 times 13.5, which is 60 3/4. The height is 7, not 6. 6 is the length of that slant. In volume, you don't even need that number, but for surface area, you would. So then you would multiply 60 3/4 times 7, and then divide that number by 2, or multiply that number by 1/2, giving you a final answer of 212 5/8 units cubed. Let's move on to surface area. When calculating the surface area of a rectangular prism or cube, a triangular prism, be it regular or right, the processes are still the same. As you watch this, what I did is I chose different highlighter colors to express which ones I was working with at the time, which sides. In the rectangular prism on the left, I found the top and bottom first, which was 7 times 9. That gave me 63. 2 sides gave me an answer of 126. The left and right sides, I used 8 by 9. That was 72. And then I had to multiply that by 2. I know that doesn't look like a 2, but it was. That gives me 144. And finally, the top and bottom, 8 times 7, which gave me 56 times 2. I added all those numbers together and I came up with 382 units squared. On the triangular prism, I started with the triangles, which was 15 and 9. That was my height. My 9 was my height. 15 times 9 divided by 2 gives me 67 and a half. There are 2 of those triangles, so those 2 are done. 15 times 24 is the base. That's 360. 24 times 12 are the 2 sides indicated by green. That would be 24 times 12, and there are 2 of them. That gives me a final surface area of 1,071 units squared. Here's an example using a right triangular prism. On this one, I chose to do the bottom first, which was 14 times 22 and a half. I then found the area of the triangles, the front and the back one, which was 12 times 14. And then I divided that by 2. That gave me 84 and 84. The back wall has the numbers of 22 and a half times 12, which gave me 270. And the pink one that you see, or purple, that's that slant. That's 22 and a half times 15 and a half, which gave me 348 and 3/4, combining with a final answer of 1,001 units squared. Now I'm working over here with the prisms, or I'm sorry, the pyramids. The first one I did is a square-based pyramid. The dimensions of the square are 7 times 7, which is 49. My triangles have the numbers of 7's the base, height's 10, that's 35. There are 4 of them. Added all together, I get 189 units squared. Here's a triangular-based pyramid. The 3 triangles that go around to the top, those are all congruent. The base one used different numbers. My base triangle numbers was 19 times 14 and a half. That is expressed down here. If you follow the logic, I did 19 times 14 and a half, and then I divided that by 2. My other triangles were 19 times 21, which was 399. That divided by 2 gave me the 3 numbers I just highlighted, 199 and a half, and the combined total ends up being 736 and 1/4 units squared. Ask in class for any more specific questions.